Hello, Tube Timers, and welcome back to another episode of Tube Time. This is the last part of the 6P1, my Sunbuck 6P1 amplifier review. In this episode, I'm going to show you all the changes that I made and the reasons why. When I first obtained this machine, I really didn't think I was going to change anything. However, Skunky, another tube timer, recognized the fact that the capacitance outside of the 5U4C was way too high. Yeah, and in fact, it is way too high. The spec sheet for this thing says 7 microfarads maximum. I kind of crowded it with 10, and some people are putting in 22. I guess that's all right. It's very important to note that the 5U4C and the American 5U4 doesn't necessarily have the same base diagram. So you have to be very careful about that. Here's your 5U4, and here is the 10 microfarad capacitor I substituted for the 150 microfarad capacitor that was there. Another thing that I did was I collected up all the grounds. And I want to show you I have 3 grounds on this system: a component ground, a speaker common, and an chassis earth ground. I broke them up so that they are actually independent grounds, and with this switch I could tie them all together to the earth chassis. Probably I should have just tied them all to the earth chassis, but I thought I'd give myself an opportunity to see which here's the best with the different type of speakers and inputs I have. The third change I made was a heater elevation circuit. And the reason will become clear when I show you the next diagram. I took the output of the right high voltage and I built a voltage divider to yield about 38 volts in the center point. I also put a 10 microfarad capacitor here to act as a analog ground. If you notice, this connection used to go to ground, and I severed it from the ground and brought it up to this 38 volts. That puts 38 volts on the heater circuits. Now, the reason why I did this is because there is a spot in the actual circuit where the voltage on the heater and the voltage on the cathode is way too high. It's almost 100 volts, and probably could get to 100 volts with the appropriate amplitude changes due to the signal, and that could cause a breakdown in the resistance from the filament to the cathode. I did the same thing for the left channel, and I've got a heater elevation here that is the same 38 volts, and I used the same circuit obviously to yield this elevation. Now, is this going to be a problem? I certainly hope not. I'm a little concerned about the VU meters. I don't think they particularly care, and I don't think this circuit cares either, because this is just a static potential. There certainly is some current behind it, but it's not really referenced to the earth in these filament transformers, because there is no earth reference in here, at least to the best of my knowledge. It was kind of nice that they had a separate right and left heater transformer, and that's kind of unusual and just surprising. Anyways, let's get on to the main circuit. The main circuit has miraculously appeared in the camera view. Oops, it's upside down here. And the changes I made were, starting at the beginning, I broke out the right and left potentiometer. They're ganged together and turned at the same time. What happened was the grounds at each one of these potentiometers were connected to the shield ground, and what that would do is give you the potential of a noise loop running around that circuit there. So I separated those grounds so that they were independent. And here's the part where the heater elevation comes into play. If you notice, this 6H8 has a cathode and it's connected to the plate of the um, first half of the 6H8C. These are two triodes in one bottle. And at that point, there's 91 volts. That was the measured potential before heater elevation. It's always 91 volts. I'm sorry, even after the heater elevation. I'll show you in a minute. The heater, which heats this cathode, was raised to a voltage of 38 volts. So if you measured the voltage on the heater with respect to ground, you'd come up with 91 minus 38 volts, and that would be the heater to cathode voltage, which is well within the limits of 100 volts on this product. The second thing I did was took the screen, I call it a screen or a suppressor, which is sort of like a suppressor in this configuration. Oh, by the way, this is the cascode configuration where they take two triodes and simulate a pentode by doing this. And the reason for doing that is to give you a very high gain on the output. Now, why they just didn't use a pentode, I can't say, but I guess the 6S7 looks good and they could use it for marketing. Anyways, this grid here used to be tied to this cathode to give you some sort of differential with a 1 meg resistor. There was also a capacitor to ground this 0.22 microfarad to bleed off any analog signal that might happen to appear at the screen. And it's going to appear because this thing is going to move up and down with the amplitude signal, changing the relationship of the cathode to the grid. So you have to stabilize that voltage like you would on any suppressor grid, tying it to the cathode. So what I did was created a voltage divider that would give me approximately 1/3 the voltage of the suppressor screen to the high voltage supply. I'm having a little jitters here as we're talking. This 1/3 HT was recommended by several sources. The one I remember the most was, what was his name? I forgot it. Anyways, he's the one that indicated to me that that's what should be done. I'm really embarrassed. I don't remember the guy's name. Merlin Blenko. He has a series of 3 books that are just outstanding books. They tell you a lot about amplifiers and what does what inside them. The rest of this circuit I pretty much left alone with the exception of the grounding system. That's part of the ground separation. So if I switch that grounding switch I showed you earlier to the other position, this component ground would be isolated from this speaker ground. There was something very nasty going on here, and that was in this headphone jack. What happened in the headphone jack was the case of the jack was silver colored and metallic, and the sleeve was connected to this silver metallic. And when you plugged it into the opening inside the chassis, you would actually short this thing out through these resistors. That was a problem. So I isolated. That was one of the reasons for isolation. And I also had to change this headphone jack to a plastic one. Let me show you the difference between the two jacks. This is the original jack. And it's a very nice jack. It looks very aesthetically pleasing on the front. And there was also a little gold insert here that connected the headphones to either 1/8 or 1/4 inch. And you can see this is the common, this is the sleeve, and this is the screw that bonded this output ground to the chassis ground through this resistor network. That's a bad thing. So what I replaced it with is this jack, which has no sleeve on it, and it was insulated from the chassis. So I effectively isolated the ground of the output from the chassis. Ah, yes, these came from AliExpress, my now becoming quickly my favorite source for components of various goods, particularly on Chinese products, because you're going to find them. You're going to find them in there somewhere if you look hard enough. They're identical. They are absolutely identical, except one is a more expensive silver metallic and the other one's a plastic. That was kind of an important change. The other thing I did was single point ground. So every one of these ground symbols goes to the second bulk capacitor, the 150 microfarad at the negative. And so every ground is directed toward that single point. That's kind of important to sort of reduce ground loops and not really change anything in the circuit. So there's the schematics of what I did. Kind of interesting, I guess. Well, it's somewhat blurry. I apologize for that. I don't have a good close-up lens for my phone here. But here is a circuit of the power supply, and here is one of the two channels. This channel is the right channel and is identical to the left. Okay, now let's take a look at some hardware. Okay, we're back looking at the hardware. Now what I'd like to show you is this is the heater elevation circuit right down in here. I sort of tucked it in. Naturally there's a wire in the way here somewhere. I'll hold it out. And this is the two resistors that go to the left or right high voltage, and the ground or the capacitor that establishes some sort of a low frequency impedance for low impedance for low frequencies. This is the center point. The other channel is tucked up there in the corner, right up there, in kind of the similar position in the same hole. If you notice, there's a new bridge or a new set of network here of diode and capacitor, and what this does is these are the components that ran the VU meter. The reason why I brought it down here and broke it out was because it was flying lead type connections where they were all connected directly to the wire, insulated with heat shrink tubing somewhat, and I really didn't like that, and I wanted to see really how this circuit works, so I unpeeled the whole thing, and then I just got interested in tying them to points rather than letting them just fly and hang out there in the wild. I guess I can thank Mr. Carlson's Lab for that. Mr. Carlson's Lab is another YouTube channel that's very, very interesting. Now, in the front, if I can get my machine up there, there's another breakout point. The headphone network that's on the that I showed you with the that grounded this jack was also a flying lead construction. So what I did with this was break it out onto terminal posts with individual connections. It's tucked in there real tight. I mean, this looks crammed now compared to what it used to, but I can live with the crammage. Let's see, whatever else. Oh, this is the signal point ground I was talking about. We'll kind of take it out for a little bit of a overall view here. Excuse the camera while I bounce it around. Up here is where the right channel heater elevation circuit occurs. This thing over here with the white wire is how I scraped traces and isolated the grounds between the left and right. This is the other, down here is the other heater elevation and the VU meter circuits. So technically I did very little to change the audio performance of this amplifier, and when I ran a frequency response on it afterwards, it was the same, which is not surprising because I didn't really do anything to the audio circuit. The only problem with this lower capacitance, it's definitely increased the AC hum in the output. You don't really hear it on the big speakers, but it's very noticeable on the headphones. So this thing is no longer suitable for headphones. I've got a fix to that, and what I'm going to do is try to add another inductor capacitor stage to the filtering of the power supply. So basically, I'm going to apologize for what is a terrible drawing here, or terrible circuit. What I'm basically going to do is add take this point here and put in another L and C to filter out the hum from that reduced capacitance. I've already tried it on the bench with clip leads and hanging out capacitor and inductor, and it was really quite surprisingly effective. And it shouldn't do much for the audio performance either. In fact, it might even give a better deep bass response if I put a little higher capacitor than 150 microfarads out past the inductor. Anyways, this is what I've done to the Sunbuck. It's kind of a nice amp. The quality is decent. The build quality is decent. The analog design is okay. But I can only ever get 1 watt out of this thing. I don't know why, but I can only get 1 watt out of it. 1.2 watts, actually. I'll probably look into that at some point, but it's plenty loud enough for me in the lab here where I am actually doing my work. Well, tube timers, that's it for the 6P1. Nothing miraculous. I know Skunky and her channel rebuilt it to a completely different amp, and I wasn't willing to go that far with this thing. I just wasn't that interested. And I invite you to go over there and take a look at her channel and see what she's done to this thing, and her Audio Karma posts on audiokarma.com. So I guess I bid you all farewell for this episode, and the next episode is going to be a rather interesting thing. It's an old candlestick telephone that we're going to refurbish for current use. Anyways, tube timers, goodbye, good luck, stay healthy, and stay safe.